This is Geometry Chapter 5 review. All right, so go with me to page 186. On page 186, I would know how to work problems 7 through 12.
On which page?
7 through 12. Okay, what's the difference in those two statements? The first statement says AB plus 10 equals CD, CD greater than EF. Therefore, AB plus 10 greater than EF. What is that? What? Miss Lydia.
Actually, 3 possibilities?
No.
No, never mind. I don't know.
Yes.
The addition theorem.
It is not the addition theorem. Here's my therefore.
Oh.
Here's my therefore. This and this, therefore this.
Oh.
Substitution. This is substitution. All right, now look at the second statement. AB greater than CD, CD greater than EF, therefore AB greater than EF. What is that? What?
Between this rays.
Addition theorem.
This is not
No,
the addition
it's-
theorem.
Trans-
It's transitive.
Yeah.
You see the difference?
Which problem is this?
I made it up.
Oh, okay.
That is transitive. All right. What is that?
3 possibilities property.
3 possibilities. Got it? What is that?
Addition theorem property.
Addition theorem of inequality. All right? What is that?
Addition property.
That's just addition. Just addition, that's right.
Uh-huh.
Yes?
Division.
It's division. Okay? I'm just making them up, right? Um, is it? It's
Multiplication.
multiplication. I multiply by 2 on both sides. Got it? Are y'all getting it? Okay. All right. So you have to know those properties on page 185. Oh, wait. Let me do one more. Okay. So I want to know the difference. And I'm going to draw an image. Maybe I'll draw 2 images. All right. So don't anybody give the answers, right? That's a 1. All right, so think of those 2 statements.
We have to find the reason.
Yes, think of the reasons. All right. Do you know this one? What is it?
I think it's whole greater than part. Theorem.
Okay, listen what you said. You said whole
Wait, it's the
greater than. Do we have a greater than sign?
whole greater than part theorem.
It's what?
Because of the part, so it can't be. I don't know what it is.
It's between
Okay.
it of race.
Is it between us a race?
Between the subrays.
The whole is
Second
greater
one
than
is
the
the
part.
No, this is between the subrays. Is there any greater than sign? Listen what you said. You said whole greater than part. Is that the whole? There's no greater than sign. So it's illogical. Got it? Your reasoning has to match the equation, the expression. What's the equation? All right? Now what is this one?
That's real great.
That's whole greater than part. Right? Part. The whole is greater than any single part. Okay. What is this? Yes?
Between us a points.
This is between us of points. And this is
Whole greater than part.
whole greater than part. You got it?
Can
All
we
right.
write like BOP and W greater than P?
No. Write whole greater than part. You can write BOR, BOP.
BOP.
Yes.
Can you quickly explain the the
Betweenness of points.
rays and between some points? I
Yes.
don't.
Betweenness of points says I can add the individual segments and they equal the whole segment. So that plus this equals the whole. That's what betweenness of rays says. Betweenness of points. Betweenness of rays says I can divide any angle into 2 separate angles. And when I add the pieces of that angle, it equals the whole angle.
Okay.
Whereas whole greater than part says the entire angle or the entire length of the segment is greater than any smaller part of it. Okay? All right, look at lesson 2. All right, so I would know those proofs on page 188 and 189. 45, 46, 47, and 48. Know those proofs. Got it?
So 47, 48.
45, 46, 47, and 48. Know those proofs. Okay? All right, exterior angle theorem. What does the exterior angle theorem tell you? Yes, David.
It's a exterior angle of a triangle is greater than the remote interior angle.
Okay? There's something else about an exterior angle. What else do you know? Yes.
It is supplementary to an interior angle.
It is supplementary to an interior angle. Why? Because it forms a
Linear pair.
linear pair. There's something else about an exterior angle.
Oh.
Yes?
Is it the two interior angles opposite of it equals to it? Like,
It's the two what? Yeah. An exterior angle equals the sum of
two remote?
the remote interior angles. Got it? Like I'm sitting at the remote. Here's the remote. You know, the TV would never be here. The TV's going to be way over there. That's why we have remotes.
Also, can it like the ones on the outside on the same side equal 360?
Okay, so give me 3 that equal 360.
6, 10, 1.
6 plus 10 plus 1 equals 360. What? Another one. Yes.
3 plus 8 is 12.
3 plus 8 plus 12 equals 360. Okay, give me 2 other equations. Or at least 2. Yes. That have to equal 360. There's a couple that equal 180. And then there's just a couple you can make. You have one.
I think just 7 plus 6.
7 plus 6 equals
180.
180. Yes. Give me 3 angles that equal 180. The sum equals 180. The sum of 3 angles equals 180. There's at least 2 equations. Wait.
7, 4, 9. Or it would be 5, 4, 9, but aren't vertical
Yes!
angles equal, so you can
Yeah.
substitute it.
4 plus 7 plus 9. Or 4 plus 5 plus 9.
Yeah.
Or what about 2 plus 7 plus 11?
That's what I was about to say.
Yes, 180. Good job.
And then
All right, what is angle 6 equal the sum of? Angle 6 equals the sum of what other 2 angles? This
4, 9.
4 and 9. Because
Oh
4
my
and 9 are,
My address is 649.
well, there we go.
Oh my goodness.
Okay? Are you with us, Beckett?
Okay.
Okay, Beckett, what does 10 equal? 10 equals the sum of what other 2 angles? 4 and 5, you got it. Yes.
Could you explain the linear pair real quick? So
Okay. Somebody explain what a linear pair is. What's a linear pair? They share a common
ray.
ray. That's correct. So a linear pair is a straight angle so that these are opposite rays. So you have a set of opposite rays and then you have a ray in common. Okay, here is not a linear pair.
They don't have to add up to anything specific.
They do. What do they have to add up to?
180.
180, yes. Is this a linear pair?
No.
Can it be supplementary?
Yes.
But are all supplementary angles linear?
No.
No. Are all linears supplementary?
Yes.
Yes. Got it?
So 1, 2, 3, and 4 is 4 linear pairs.
There's an alien.
You can do 1 and 2.
Yes. 1 and 2, 2 and 3, 3 and 4, 4 and 1. Yes. What is 1 plus 2 plus 3 plus 4 equal?
9 plus 10.
360.
360. All the way around is 360. All the way around is 360. Yeah, you were adding the actual numbers, right?
Yeah.
Okay.
How many proofs are going to be on?
At least 1.
What's like the most there could be?
2.
Okay.
Okay. All right. On lesson 2, I have written on page 193, know how to work 26 through 30. Know how to work 26 through 30.
Page.
Page 193. All right, let's look at lesson 3. Triangle side and angle inequalities. All right, so I'm going to draw a couple of triangles on the board. Okay. All right. All right. So in this triangle, what would be the largest angle? Give me the angles. Large, we'll call it medium and small. Largest to small, okay? Start with the largest angle. Actually, we're going to ask you, Micah, right here. Largest angle in this triangle.
Is
Angle A. Leah, what's the smallest?
Is it angle B?
Is it?
I think so.
Yes.
Okay.
All right, so that would be them ordered largest to smallest. Got it? Hannah, look at this one. What's the longest side? Almost said the largest angle. What's the longest side?
FE.
FE is, we'll write that. FE is the longest. All right, shortest side. Mary Frances. FD. Did you say FD? So the one in the middle would be DE. Got it? Y'all can do that? That's what this lesson was about. All right, ordering them by their side, okay? Now, what if I tell you that BC is greater than AB? If I tell you BC is greater than AB, then what can I know?
AB is less than BC.
Okay, I can know that, but there's something else I can know. Wait, angle A
Angle C.
angle C. Why?
It's
When two sides of a triangle
are
are
the
unequal,
remote.
the angles opposite them are unequal in the same order. So if this one is greater than that one, then this one is greater than that one. Got it? Okay, now what if I tell you angle E is greater than angle F? All right, Lily, what can we know? Yes. Do y'all see that? Yes.
On triangle ABC,
Yeah.
what do we know about like the AC side to B? Would they be equal?
We don't know that. Only thing that was given was BC is greater than AB. All right, that's all this lesson.
Could you also know that angle F is greater than angle E?
I can't know anything else.
You can't know F is
I
greater
can't
than
know any relation to D.
Okay.
All right, so here's the problems I've written down for lesson 3. Are you with me? 4 through 20. I know 4 through 20. And then 45 through 49. Okay, 4 through 20 is on page 197. 197, 4 through 20. And then on page 199 is 45 to 49. All right, look at lesson 4, which is what we just did.
How many lessons are there?
4, that's it. Yes. This lesson talked about the sum of any two sides of a triangle has to be greater than the third in order for that shape to be a triangle. So if I had 20 and 22, could we figure out the possibilities
Yes.
for that?
Probably.
Yes.
Okay, what are the 3 inequalities that I'm going to write?
20 plus 22 is greater than x. 22 plus x is greater than 20. And then 20 plus x is greater than 22.
That's the 3 inequalities. One is always not going to make sense. Well, this is just 42 greater than x. Does this one make sense?
No.
When I subtract 22, I get a negative. You with me? That's the one that doesn't make sense. The last one, when I subtract 20, x has to be greater than 2. I'm okay if you circle these, or you could write it as one. This is called a compound inequality.
It's okay if you write 2 is less than x.
Yes, you can write 2 less than x less than 42. It'll take my brain a minute to check it, but yes. Got it?
Do we have to do like the 3 steps on the test, or like do we have to, like?
You have to write the 3 inequalities. Yes, you do. Okay, tell me what you know about an equilateral triangle. What do you know about an equilateral, David?
All angles and sides are equal.
No, I said, listen to what I said. Equilateral. What is it, Hannah?
All the sides are
All the sides are equal. Then once I say all the sides are equal, can I say all the angles are equal?
yes.
Yes. But I can't go from equilateral, I have equal angles. I have to somehow prove that equilateral means equiangular. And that is true by definition, okay? What if 2 angles in a triangle are equal? What kind of triangle is it? 2 angles. Everybody think 2 angles in a triangle equal. Beckett? No, Beckett. It's isosceles, that's right. What if no angles in a triangle are equal, Micah? No angles are equal in a triangle. It's not isosceles. No angles in a triangle equal. It's scalene. That's right. That was on Jeopardy. Did I already tell you that? That was on Jeopardy, yeah, really.
You said congruent.
Oh, congruence was on Jeopardy too, but so was the scalene triangle.
Did they get it?
So
No, they rarely get the math ones. Yeah. Okay, you have got to understand the difference between transitive and substitution. That's where I started, right? You have to know the triangle inequality theorem on page 201. Page 201. You have to know the triangle inequality theorem. Can vertical angles never be equal? Can there ever be a case where vertical angles are not equal? And say no. That is correct. All right, look at this lesson 4. I have written 10 through 31. Those are the problems you should know how to work. 10 through 31 on page 202, 203.
Is this on like the homework?
I don't know. When I make up your review, I look at the test and I look at the book. So if you don't write it down, well, sadly now it's in video. Good for you. All right, so now look at the review. Here's the problems I like from the review, a whole lot. I like 15 through 25. I like 41 through 46. And 49 and 50 are both proofs. I would absolutely know how to work those proofs.
And that's on the number
Review.
5. Oh.
That's the review. All right. So let's work number 50. That is a proof. And then we'll stop. All right. Number 50. Here is the image. I always like to have the image in front of me because I mark it. Okay, what's the first given statement? What's the first given statement?
Point X on side of AC of triangle ABC such that XB is equal
Okay, let's
to
just leave X is on AC. All right, that's the first given.
and then XB equals XC.
The second given is XB equals XC. All right, I'm going to write up here what I'm trying to prove. I want to prove that AC is greater than AB. All right, now look at this first statement. What can I know from this first statement? If X is on AC, then I can know, say it, AX plus
XC
XC equals AC. Why can I know that?
Oh.
Between us
points.
of points. I can know that because it's between us of points. Got it? That's between us of points. Okay. Now I know that XB equals XC. Did I write that correct? Okay. What can I know from that? That equals that.
That the angles opposite are equal.
Okay, so what angles are equal?
B and C.
Well, angle
Well,
XBC,
and then is equal
angle XBC
to is equal to angle C.
equals, yeah, I'm gonna use 3 letters, XCB. Why?
Because when lines in a triangle are equal, their angles opposite are equal.
Yes, when sides of a triangle are equal, the angles opposite them are also equal. All right, so we have some equal angles here. I want to get AC greater than AB. All right, where am I going from here?
This,
Yes.
should we write the name of the theorem on number 4 instead of writing that?
No, this is what I want you to write, because names of theorems change with textbooks. And if you take a test anywhere outside of this class, they're not going to use the names of the theorems. This is what they're going to ask you. Okay?
I find it easier to just like explain why.
Explain it. That is correct.
Oh wait, could you like substitute XB and then C equals B? Or you need to do that?
Wait, say that one more time.
So since XB is equal to XC, could you like substitute it on the angle
Well,
side?
I could. That's not an angle. This is a side.
Oh.
So I'd have to substitute it in here. But what can I say about, okay,
Okay. So XC is.
what What about this
And
angle? What can I say about that angle? What is it made up of?
ABX and XBC.
So angle ABX
Oh,
plus angle,
XBC.
I'm gonna say XBC. XBC equals angle ABC. Why?
Between the rays.
Betweenness of rays. Okay? Alright, so look what we have. We have some angles. If I can get angles greater than other ones, then I can say the sides opposite them. Alright, so let's see what angle is opposite AC.
B.
The whole angle B. What angle, alright, this is the whole angle B. Angle ABC. What is opposite AB?
C.
A, C, B.
Or
C, C, A.
B, ACB, either one. I'm just gonna write angle C. Alright. Do we have ACB anywhere?
Yeah.
Oh, but we have it's equal to something. Okay, we have it's equal to something. Okay. Alright. Now, can I say ABC ABC is greater than which one? Where do I want to go? ABC greater than XBC? Can I say that?
Yes.
Okay, angle ABC greater than angle XBC.
Oh, and then
because, is it because?
all greater than part.
Yep, that's what I was gonna say.
Whole greater than part. Okay, so I have this angle as being larger than XBC, than that one.
And don't you substitute?
Wait. What are we doing? Yes?
Then you
So angle ABC greater than
XCB.
XCB. What are we done?
Substitution.
Substitution. Now do we have it?
Yeah. But
What's opposite ABC?
AC?
AC. So AC greater than, what's opposite XCB?
Angle C. No.
That's angle. What's opposite angle XCB?
B.
AB. Why?
Because when lines or
When
sides
two angles,
in a triangle are
when two
unequal,
angles in a triangle are unequal,
their sides opposite are unequal
yes,
in the
the
same order.
sides opposite them are unequal
In the same order.
in the same order.